We're here, deep in the Amazon, looking for a species on the edge of extinction. It's not a jaguar or a sloth, and it's not even a single species, but a collection of them. Frogs, like many of the world's amphibians, are being wiped out by the deadliest plague you've never heard of. And if we don't act fast, they could be gone for good. Let's talk about that. Except certain salamanders that can extrude sharp venom-tipped ribs and two species of frogs with venom-tipped bones on their skulls, amphibians aren't venomous since they don't actively inject their venom. Instead, they're poisonous since they unload their toxin when eaten by other animals. Whereas there are almost no venomous amphibians, the world is filled with poisonous ones. There are more than 170 species of poisonous frogs, mostly concentrated in South America, in the poison dart frog family. Named for the native Indians, they used darts tipped with the frog's poison to hunt animals for hundreds of years. Although, of those 100+ species of poisonous dart frogs, only 4 were ever used to weaponize darts, even though the whole family ended up sharing the name. Despite their lethality in the wild, you can actually get one of these frogs as a pet, and they'd be completely harmless. That's because the frogs don't make their own poison, but rather sequester it from what they eat. They take up a deadly chemical called a lipophilic alkaloid from consuming poisonous insects and plants in the rainforest. The poison then accumulates in their bodies and they secrete it through their skin as a defense mechanism against predators. This poison is then absorbed through the victim's skin and prevents their nerves from transmitting impulses, eventually leading to a heart failure as the muscle tissue making up the heart fails to beat properly. And these toxins are incredibly stable. So stable that wild frogs can maintain their lethality for years in captivity, away from their natural, poison-containing food source. Although, even without this food source, they still maintain their flashy colors. The deadliest of this family is the golden poison frog. Their dose can vary based on location and local diet, but on average, the golden poison frog holds in its little body 1 milligram of poison. Now, that might not sound like a lot, but that's enough to kill about 10,000 mice and between 10 and 20 humans. The golden frog's exceptional toxicity comes from its extraordinarily rare and lethal poison, batrachotoxin, found in only 3 other poisonous frogs and a handful of other species. The poison attacks the sodium channels in nerve cells. These sodium channels are the basis for electrical activity in nearly all organisms, and first appeared in cells about 3 billion years ago. As life propagated outward from those early single-celled eukaryotes, it carried with it these sodium channels, and now nearly every organism alive uses them from their shared common ancestor. They're one of the few descended traits common across the vast majority of life, and since the poison blocks these channels from functioning, it works against most living animals. But if a single frog has enough poison to kill 10,000 mice, how is it fine just hopping along? Well, that's because these frogs have adapted very specialized sodium channels, shaped so slightly differently that the poison won't work, but similar enough that the sodium channels still function like normal. But these poisonous frogs, and all amphibians for that matter, might be coming to an end. An infectious disease has been spreading around the world, infecting amphibians and wiping them off the map. A fungus named Batrachochytrium dendrobates was first discovered in the poison dart frog in the late 1990s. Since then, it's been found on 6 continents and infected more than 40% of all known amphibian species. In a short period of time, BD has contributed to the threatened status of more than half the species it's infected, having an even greater impact on the species than human-led deforestation. While humans didn't create BD, they've had a huge impact on spreading it. It's hard to know exactly where BD originated, but we can get an idea by studying old museum species for the telltale signs of skin infection. So far, the oldest known instance is from South Africa in the 1930s, and geologists think it may have spread around the world in African clawed frogs, which were once used as pregnancy tests. Back in 1930, a scientist based in Cape Town discovered that he could use ox hormones to control ovulation in a local frog species. By 1933, doctors were using the frog to detect HCG, a hormone produced by pregnant women. When a pregnant woman peed on the frog, it would lay eggs within 8 to 12 hours. The test was both rapid and reliable, and so it spread quickly throughout Europe and the United States over the next 2 decades. Unfortunately for modern frogs, it was much easier to import these frogs directly from Africa, rather than growing them domestically, allowing the unknown disease to be spread by physicians around the world. BD is the only known fungus of its kind to infect living vertebrates. In amphibians, it attacks their skin, which they normally use to breathe and take up water. BD interferes with this process, suffocating their victims. And infected frogs seem to get froggy delirium. They become extremely sluggish, often can't right themselves if turned upside down, and will hop around in circles aimlessly. All of the handful of major strains of BD have turned up in amphibians involved in the international commercial trade, showing how the infection continues to be spread today. The disease can be traced back at least 90 years, but it's been spreading exponentially since, and now the situation is becoming increasingly dire. Despite not getting any news coverage, face it, it's almost guaranteed you've never heard of it. It's wiping out frogs left and right. The last decade saw 3 times more amphibian species go extinct compared to the 90s, and the primary cause of extinction in 90% of those species was BD. Mortality rates can vary wildly and are highly species dependent, but generally speaking, a significant percent of infected amphibians end up dying, and some species, like the ornate burrowing frog, have a 100% mortality rate when infected. Many scientists have argued that we're currently in the 6th mass extinction event, fueled almost entirely by humanity's effect on the planet. This claim is backed up by the near 10,000-fold increase in species going extinct we see today, compared to non-mass extinction time periods. The result, the mass extinction of amphibians, which make up more than 10% of all vertebrates, may be slipping by unnoticed. The spread of BD also shows the continued failure of international biosecurity measures to keep BD and other infections contained. One thing's for sure, if things continue on their current path, we might not have our little green friends hopping around much longer. I hope you enjoyed getting smarter with us today. If you did, be sure to subscribe so you never miss an upload. And remember, there's always more to learn.